Have you ever wondered how far you can take a simple Excel spreadsheet? From a basic financial table to a fully interactive app with navigation and edit forms, watch this. Let's get started and I'll show you exactly how to build it step by step. First, head over to OneDrive for Business and sign in. OneDrive for Business is a cloud storage file hosting service that allows users to sync files and later access them from a web browser or mobile device. Connect to OneDrive for Business to manage your files. You can perform various actions such as upload, update, get, and delete files. You can perform these actions with the Power Platform connector. I will later add this to the Power App. For now, this is the most simple and easy way to host our files so that we can later access it in the Power App. I'll next head over to the Power Apps homepage by navigating to make.powerapps.com. Once you get to the homepage, select Create from the left navigation pane. Choose the Create from blank and then select a size for the app. I'll then delete the controls which come with the app by default, as I'll be adding my own later. From the App Authoring menu in Power App Studio, select Data, Add Data. Expand connectors and from the list of connectors select OneDrive for Business to add it to the app. I then find the file I just uploaded to OneDrive and create a connection to it. Once a connection has been established, you'll see the notification below the formula bar. A connection has now been established. The next step is to display and manage the data from the data source. I do this by adding a gallery control. A gallery control can control multiple records from a data source, and each record can contain multiple types of data. Each data field appears in a separate control within the gallery control, and you can configure these controls in its template. The template appears as the first item inside the gallery. I adjust the gallery control's X and Y values to make sure it starts at the top left of the screen. I then adjust the width and height so that it covers the whole screen by referencing the screen as the parent. This makes sure that the controls within the app are resized along with the app, and as a result, the app is responsive. I'll then delete the controls that came with the gallery by default, and begin to shape the gallery template. You can see that the changes are replicated in the rows below. This is the advantage of a gallery control. I do this by adding label controls to the gallery template which use this item dot, followed by the column name. This allows us to reference each row in the Excel file. Inside the gallery template, I want to make sure that the label controls are resized automatically. This is achieved by adding a horizontal container and then adding the labels in this container. I edit the properties of the container similar to how I did with the gallery control, referencing the template instead this time however. Here's a mistake that breaks most Power App galleries. If you reference the parent instead of the template, your layout will fall apart. Always anchor to the template so every item behaves perfectly. In the formula bar, I do this by using the name of the gallery and then either the template height or template width. This is best practice and keeps your app scalable and consistent as it grows. I delete the old label control and add it to the new container so that it can be resized with the new properties which it will inherit. I add the reference to the column name once again and then the value is reshown for each row. I open up the Excel file again so that I can remember each column name, as I will later on be adding a label control for every column present in the table. The table opens up in WebView and then I'm able to switch back and forth between the tabs to view the column names and reference the values. I begin once again by adding the name of the first column and then editing the properties. I enable auto height so that the label's height is resized automatically if it needs more height, and turn on flexible width so that the label uses up as much space in the container as is necessary. I then rename the label so that when taking a look in the tree view, I'm clearly able to reference the controls and what they are for. I then copy and paste the label controls so that the properties I set are carried over to each of the new label controls. I need the same number of controls as there are columns in my Excel file so that I can reference all of the values I would like to display in the app. I switch tabs back to the Excel file so that I can count the number of columns there are. This will give me the number of label controls I need. I won't be displaying the Power App's ID, so in total I have 16 columns and will therefore copy and paste the first label control 15 times. This is a long process, so I sped this step up. You can copy and paste with Ctrl-C and Ctrl-V, just like in other Office apps. But here's why it's so powerful. Behind the scenes, these controls are defined in YAML, so when you copy them, you're duplicating their full structure and properties instantly. That means you can reuse and scale components much faster without rebuilding anything from scratch. I then go ahead and do exactly what I did with the first label to the other labels. This is so that they reference each unique column and not the same column. As well as editing the value inside, I make sure to change the name of the control. Now, if your values look wrong, it's usually a data type issue, not your app. In my case, the month name column was set to accounting in Excel instead of text, so Power Apps couldn't read it properly. After fixing it in Excel on OneDrive, make sure you fully refresh the data connection, and if needed, remove and re-add the reference in the formula bar. It's a bit tedious, but it guarantees the correct values show up. In the app in Excel, I follow these steps and you're able to see once I delete the reference in the label, refresh the data connection, and re-add the reference in the label again, the correct value is shown. This is an issue that can only be discovered if you check the values yourself, as there is no syntax issue or runtime error discovered by the app checker. It's a user mistake. With this common issue now resolved, I place the app in preview by selecting the play button seen in the app actions. Another issue is now visible, is that the values are cut off of the screen. In order to fix this issue, we'll need to once again configure the layout, and make sure that a scroll is available to the user so that they can navigate all of the values in the app, similar to an Excel sheet. To do this, you'll need to insert another container. The container can hold a set of controls and has its own properties. Containers affect app layout and help screen read users understand the structure of the app. Insert a horizontal container and add inside of it the gallery by dragging and dropping it into the container from within the tree view. You then set the properties of the container the same way we did previously with the gallery, to make sure that it is responsive and references its parent, the screen. Now select the template container from within the gallery control. The width here is adjusted as it has been added to another container. Set this back to what it was previously. I do this by copying and pasting what is in the height property, as the width references the same, just instead the template width and not the height. With this modification, the gallery template now displays as it was previously. We now need to adjust the layout by adding to the width and provide a scroll bar. This can be done by selecting the gallery in the tree view, adjust the minimum width so that we have more space. I set mine to 2000. This should provide plenty more space for the label controls to be resized by the container. Select the outermost container once again, and change the horizontal overflow property to scroll from hide. This will then show the scroll bar which the users can use. I temporarily place the app into preview by pressing the Alt button. This is how users will be able to use the scroll bar. The app now looks as it should. The next step is to add the header to the Excel-like table app we already have. To do this, add another container to the app. This will be a horizontal container, the same as the gallery template. This is so that the labels can be placed beside each other in the same way as the rows. Also add a vertical container, so that the container with the gallery inside and the container with the headers will be placed on top of each other. Place both of the horizontal containers inside the vertical container. Edit the vertical container's properties so that it is now covering the whole screen and is placed in the top left of the app. Do this by editing the X and Y to 0, as well as the width to parent.width and the height to parent.height. Once this container covers the whole screen, edit the top container, which is for the table headers, to the same size as the gallery template height. First, turn off the flexible height, as this will remain the same for the table headers. Instead of entering a random value for the height property, click on the first row of the gallery, and copy the template size. This will make sure that the table headers have the same height as the rows. The template size is 104, therefore you need to make sure that the table headers container is the same size by adding this value. Once adding 104 to the height property, the controls look the same. One more issue I can see is that the columns seem to be misaligned. This is due to multiple controls containing the values inside of their padding. I will remove the padding from these controls. This will then realign the columns and make it seem as though the table headers and gallery are above and below one another. Another issue is that the table header has a different width to the gallery control. Taking a look at the gallery's minimum width, we can see that it's 2000. You will need to add this minimum width to the table header container also, so that they are aligned. I add the gallery width directly to the table header container by referencing it as a sibling control. This is another way of making the app responsive. Once this value is provided in the minimum width, you can see that the containers are the same width. When I hover the mouse over the control, you can see that it extends over the primary canvas. I'll then add the label control to the top container. I'll set the properties of this label control the same as I did with the gallery template label controls for the values. This is so that they are aligned once the padding is removed. I'll turn on the auto height and check the other label control properties by selecting them in the tree view, so I can draw a comparison. I'm able to switch back and forth so that I can easily copy over the values. I'll turn on the flexible width, and then change the text property to a hard-coded value, which is the column name for the value below. In this case, it's segment. I'll copy and paste this control so that I have the same properties for the others to speed things up. Make sure that the label controls are pasted in the upper container we are using for the table headers. I've sped this part of the video up. Make sure to rename the controls, as well as add the hard-coded values for the column names. A quick way I added the column names was to switch back and forth to the spreadsheet in the web view as I have it open in OneDrive. I copy the name and paste it into the text property, as well as add it to the name along with header. You can see how I do this with the first two label controls. I'll cut to the finished table headers, as this part is easy to follow. The next issue is to do with the layout. Therefore, I'll once again be configuring the layout, this time for the container which has the gallery inside of it. The minimum width was left unchanged, therefore I will change this so that it is not restricting the width of the gallery by referencing the gallery1.width. Changing this, you can see that the controls now fit well within one another. When I scroll, you can see the table headers are in line, and are yet to be finished naming. I did this layout change when I was in the middle of this process. The next step for the table headers to be fully in line is to edit the padding of the controls so that there is no padding. You can see when I select certain controls that they have values in all their padding properties set to 8. I remove these values by selecting them and adding 0. There are 3 controls I do this for, and once complete the columns appear better aligned. This is an important step not to miss. The three controls in my app are Container 2, Container 3, and Container 1, which is inside of the gallery template. I'll later change the name of the controls in order for them to be easily identified in the tree view. After removing the padding, you can see that this looks much better and replicates what we have in the Excel spreadsheet. Hovering over the controls, you can see the difference from earlier. The blue border around the controls shows that auto-hide is enabled. Once you've renamed your labels and aligned everything, don't assume it's done. This is where a lot of people slip up. You need to double check that the values from the Excel are actually displaying correctly, because even a small data type mismatch can throw everything off. For example, notice how the date is showing a full date time instead of just a date. That's an easy fix. Select the label, update the text property using the text function with this item.date and format it with datetime_format.shortDate. Now it matches the Excel values, but one extra step most people miss is setting the locale to ENGB, so the format is exactly what you expect. Once adding the locale, you confirm that this format is correct, and you see this in my app. This is how I expect the value to be displayed. I then move on to renaming the controls, specifically the containers, and this is where your consistency really matters. Make sure you're using a clear, repeatable naming convention, because as your app scales, this is what keeps everything readable, maintainable, and easy to debug. Next, I name the screen appropriately and visually separate the table header by updating the container's fill color to blue. But here's something important. Blue on black creates poor contrast, which hurts readability and user experience. So instead of fixing each label one by one, I hold Control and select all the header labels at once. This lets me update the color property in a single step, switching them all to white for much better contrast and a cleaner, more professional UI. A quick tip: group related controls into containers early and keep your layout structured. It makes future edits much easier. Also, don't rely on default names or styles. Taking a few seconds to organize and standardize now will save you a lot of time when your app becomes more complex. And if you're building anything reusable, this is the point where you should start thinking about turning sections into components. As soon as you enable auto-height, you might notice your text starting to stack or overlap. That's a layout issue, not a data issue. To fix this, I adjust the minimum width of the controls within the container so the text has enough space to stay on a single line. But don't just fix the header, make sure you apply the same adjustments to the values below. Otherwise, your columns will fall out of alignment. Keeping both the header and the row values consistent is key to a clean, structured layout. Now, when I switch to preview mode, you can see everything responds properly. The controls resize automatically, the layout stays aligned, and nothing overlaps. And this is a real benefit of using containers and proper parent referencing. It handles responsiveness for you without needing complex formulas. The next step is to add an edit form on a separate screen, which allows the user to view, update, and submit changes back to the data source. In this case, your Excel file. Start by inserting a new screen and give it a clear descriptive name. I start by adding a new screen using the blank template and name it Screen Form, following the same naming convention to keep everything consistent and easy to navigate. Next, I configure the gallery so that when a user selects a record, it passes the item over the form screen. To do this, I update onSelect property of the label controls inside the gallery template. This is where the interaction happens. Rather than doing this one by one, I select all the relevant label controls within the template and update the onSelect property in one go from the Properties panel. This ensures that no matter where the user clicks within the row, the same logic runs, navigating to the form screen and passing through the selected record, ready to be edited. The formula I use is navigate, screen form, screen transition.none, selected record, this item. Here's what's happening. Navigate tells Power Apps to switch from the current screen to another screen, in this case, screen form. Screen transition.none controls the visual effect as the app moves between screens, making it smooth and professional. The last part, selected record, this item, creates a context variable called selected record on the form screen and sets it to the record that was clicked in the gallery. This item references the specific row in the gallery that the user selected. By doing this, the form screen automatically knows which record to display, so users can immediately view and edit the correct data without any extra clicks or setup. Now that we're on the form screen, the next step is to add an edit form and connect it to our data source, in this case, the financial spreadsheet. Once you insert the edit form, you set its data source property to the Excel table, which allows Power Apps to load in the structure and available fields. From there, the key step is setting the item property of the form to the record we passed through, in this case, the selected item variable. This tells the form exactly which row to display and edit. Once adding this variable, you'll need to add fields to the form in order to provide visibility of the record which is passed over from the initial screen. When you select the Edit Fields link, you'll see all the fields from your data source displayed. You can then start checking which fields to add. I'll add all the fields to the form. After I've done this, I select the Add button, and then reposition the form so that it covers the whole screen, similar to the other screen. This includes setting the X and Y values, as well as referencing the parent. After repositioning the form, I adjust the layout by setting the number of columns. By default, the form is set to 3 columns, but I increase this to 4. This gives me more horizontal space to work with, reduces unnecessary vertical scrolling, and creates a more compact dashboard-style layout that's easier for users to scan and interact with. Next, I go through each data card to make sure the fields are displaying correctly. For example, the date field is currently showing time values as well, which isn't needed in this case. To fix this, I first unlock the data card. Power Apps locks these by default to protect auto-generated structure, so you won't be able to make any changes until it's unlocked. There's a clear option in the Properties panel that allows you to do this. Once unlocked, I can remove the unnecessary columns inside the card, specifically the minute, separator, and hour input controls, so I'm left with just the date input. This gives a much cleaner and more relevant user experience, tailored to the actual data requirements. Next, I need to fix some formula errors that appear after modifying the form. You'll notice a small error icon on the control. Clicking this opens the details and highlights the problematic formula in the formula bar. In this case, the errors are happening because the formula is still referencing the controls I just deleted, like the minute, separator, and hour inputs. To fix it, I carefully remove these references along with any leftover parentheses or numbers that were part of the original structure. Finally, I adjust the datetime function to adjust the date function. This ensures the form only passes the date value without including unnecessary time information. By doing this, the field works cleanly, avoids errors, and displays exactly what's needed from the Excel data. I then adjust the Y value of the error message control. This is referencing the old hour value and should now be instead referencing the date value control. Now, I adjust the date value control so it matches the width of the other data card value controls. To do this, I copy the parent.width -60 formula from one of the other controls and paste it in the width property of the date value control. This ensures that the date field lines up perfectly with the rest of the values, keeping the form uniform and visually consistent across all the data cards. Next, I reposition the form slightly to make space for a back button. I do this by adjusting the Y property to move the form down, and I tweak the height property by subtracting 50 from the existing formula. So instead of parent.height, it becomes parent.height minus 50. This creates exactly enough room at the top for the back button without overlapping the form content. Then I insert the back button using an icon control, choosing the standard back arrow. I position it in the top left corner of the screen by editing its X and Y value properties, and set its height to 50 pixels. The same space I reserve with the form adjustments. This way, the back button is perfectly aligned, visually balanced, and easy for users to interact with. I then add an additional card by going in the form fields, clicking the ellipses, and selecting Add a custom card. This gives me a place to insert a submit button directly within the form. Once the button is in its place, I'll make some small adjustments to the other fields to ensure all controls have the same height and styling, keeping the form consistent and professional. I sped up this process in the clip to save time, but these tweaks make a big difference visually. Next, I will change the text of the button to submit, so it clearly communicates its function to the user. This button will eventually handle sending all the edits back to the Excel data source when clicked. Finally, I add the submit form function to the onSelect property of the submit button. This function tells Power Apps to take all the data entered or edited in the form and save it back to the connected data source. In our case, the financial spreadsheet. To do this, I first locate the form in the tree view to find its name, which is initially Form 1. I pass this name as a parameter to the submit form function so it knows which form to submit. After that, I rename the form control to a more meaningful name so it matches our naming conventions. Power Apps automatically updates the submit form formula with the new name, keeping everything linked correctly. Next, I tidy up by collapsing all the controls in the app, which make it easier to navigate, and I edit the onSelect property of the back button to include the back function. With this in place, the form screen is now fully functional. Users can navigate to the form, edit the selected record, submit their changes, and then return to the gallery, all seamlessly. Placing the app in preview mode is a great way to see how your navigation works in real time. And here's a key tip. Always check that your labels are correctly set while previewing. For example, I noticed one label hadn't been renamed properly, so I fixed it. This is a simple step, but catching small mistakes like this now saves headaches later. Next, I see that the value below this should be displayed as a currency. To do this, I edit the text property of the label and use the text function along with the value to format it correctly. Essentially, value converts the data from text to a number if needed, and text applies the formatting so it applies as a currency. Once I've got it working for this label, I copy the same formula and apply it to the other label controls that need currency formatting, keeping everything consistent across the app. There are a number of labels that need updating to display correctly, but referencing the spreadsheet, I identified the labels that require formatting as sales price, gross sales, total sales, cost of goods sales, and profit. These are all financial figures, so displaying them consistently is really important for clarity and professionalism. As previously mentioned, to format these values, I use a combination of value and text functions. One really powerful feature in Power Apps is that you can customize this formatting for different locales. For example, you could display amounts in pounds for the UK, euros for Europe, yen for Japan, or any other currency your app needs to support, making it flexible for international users. After applying the formatting, I place the app in preview mode again to see how a user would experience it. Right away, it's clear when navigating to the form, some of the label controls on the previous screen also need updating. Specifically, the value input controls in the form are still displaying numbers as plain text rather than formatted as currency. To fix this, I use the same formula applied for the gallery labels. I unlock the necessary data cards and adjust each field that needs updating. This process can take a bit of time, so in the video I sped it up, but it's an important step to ensure that the currency formatting is consistent in both the gallery and the form. Once the form updates are complete, it's important to let the user know that the changes have been successfully submitted. To do this, I add a notification in the onSuccess property of the form. This property is triggered automatically whenever the form submission is successful, meaning the data has been saved back to the data source without any errors. I use the notify function to display a simple, clear message to the user, and I set the notification type to success so it appears with the correct styling and emphasis. Power Apps also supports other notification types like error for failed submissions or information for neutral messages, allowing you to provide contextual feedback depending on the situation. Finally, I add a second back function in the same onSuccess formula, separated from the notify function with a semicolon. This ensures that after the success message appears, the app immediately navigates the user back to the previous screen, creating a smooth and intuitive experience. Once this final step is complete, the app is fully functional. I can place it in preview mode again, this time using the play button to see it in full screen mode. Here you can see all the data displayed just like an Excel spreadsheet, but now in a responsive design, with a horizontal and vertical scroll bar that adapt to the screen size. From this screen, you can select any row in the gallery by clicking a value, which takes you to the form screen. In the form, you can edit the record's values and then save your changes by selecting the Submit button. I go through and change a number of fields to make sure the form is working correctly. This includes testing the date calendar, which is important to verify that the date value is being passed properly, especially since we removed the time component earlier. Once submitted, a notification confirms that the form was successfully saved, and the app automatically navigates back to the gallery. Here you can immediately see that your changes have been written back to the data source, completing the full round trip from Excel to a fully interactive Power Apps experience. If you'd like more full, comprehensive step-by-step videos like this, leave a comment below and make sure you're subscribed for weekly content. Subscribing ensures you won't miss any future tutorials, tips, or tricks that make building apps faster and easier.